Karthik Muthuswamy is senior data scientist working on machine learning research to develop intelligent applications or enterprise software. Experience with leveraging machine learning for developing a wide range of applications. Conducts enablement session for software developers to jumpstart their journey on developing applications that use machine learning. Actively learning about human-centered machine learning and eager to bring it into the mainstream machine learning application development. Let's give a warm welcome to Karthik Muthuswamy.
Good afternoon and good evening, probably. I'm Karthik Muthuswamy. What I will do now is basically this is a talk on how we can train deep neural networks with tensor processing units, something that Google has developed. And so what we will do in this session is probably I wanted to keep it interactive. So what I will do is I'll show some demos and I will also share some links so you can also take it home and you can run all these notebooks yourself. So let's probably start. I will begin with myself. I'm Karthik Muthuswamy. I work for SAP as a senior data scientist. So my task at SAP is to develop deep neural, I wouldn't say deep neural network, I would say machine learning models for enterprise software. So basically to understand how customers probably write about, say, emails, or are they happy, are they sad? Can we actually understand different languages? How do we say understand if it's German or if it is English, and if people are complaining in English or in German, and how do we make the steps faster? How do we make things easier for, say, the customer agent who's reading our emails to process our emails, so customer inquiries or anything like that. So that's one part of my my job at SAP. One of my other tasks at SAP is also to do enablement sessions where I talk about machine learning, basically to make people understand what machine learning is about. And one of my biggest tasks is to make sure that people understand that machine learning is not artificial intelligence. This is a misconception. That people think that what we are doing is artificial intelligence while we are doing extremely good mathematics, extremely good computation, and extremely good machine learning is what we are actually doing at the current instant. So my talk is also targeted is to make sure that people understand that machine learning is not the same as artificial intelligence at this moment. So we are not at this state where we can actually say the machines are artificially intelligent. So that's also one of my tasks. I'm also a Google developer expert, which means that I get to travel across the world and to basically to teach people about some of the Google technologies. So for example, TensorFlow is one of those. I also talk about Google Cloud. How do we marry these two technologies together to make a very nice, good-looking application in the end of the day. One of my other big tasks for me is to also make sure that there's this human-centered machine learning is one of my biggest areas of interest, basically to ensure that human beings are not being replaced by machine learning. So basically, the idea is to make sure that customers and companies understand that whatever we are doing with machine learning is not to replace human beings, but to basically help human beings in making their tasks easier and making it faster. So in that sense, this is one of my core areas of interest. And what I will do now is probably, because I don't want to keep on talking, probably let's get into some of the fun things that we will do already. So let's get started. Probably it's too loud. Yeah. So okay. So to begin with, let's start with. So the reason why I want to start with the demo is because this way you understand already what is the motivation for using something like, say, for example, TensorFlow. Why is it good? Why is it bad? We will go through all of this. But before we start, I just want a quick show of hands. How many of you have used TensorFlow before? Okay. That's nice. So for people who don't have an understanding, or this is the first time you're seeing TensorFlow in action, then welcome. You are in for probably a delight. This is a very good time to get into machine learning and to actually learn about machine learning because this is actually a very nice time where you get all the resources for free, I would say, and for also the fact that we are at a very good state where a lot of the algorithms are also mature enough. So what I will do is I will start with one of the first things, which is playing Pac-Man. So I already have Pac-Man loaded here. So as you can see, this is a web browser. So the coolest thing here is that everything on this entire screen is actually running on the browser, on my current browser. And what I'm going to do is to play Pac-Man purely from the browser and without touching the screen. So this is also a motivation for machine learning and how machine learning actually learns. So in this case, as you all know, Pac-Man has 4 moves. You either go up, you go down, or to the right, or to the left. What we are going to teach this machine learning algorithm is to do exactly that. But what we are going to do that is with images. So let me show you what that I mean. Let me start with, say, for example, this is going to be, maybe let me, it's happening over there is you can see on the screen, it's collecting image samples. So this is exactly what a machine or a data scientist would do, is to first gather data. And this is one of the things. So the first thing is I'm taking the images for the task up. Now next, let's do for the task down. Probably let me give a new gesture. Let me give this as a gesture. Now again, you see the top level, let me talk after that. So yeah. So we have 42 images for one gesture, 42 images for the second movement. Let's do one more, which is, say, this is to go to the left. So let's collect left here. And hopefully, we are collecting, OK, moral is there. So yeah, probably 46 samples, not bad. Let's do right again. And here, what's going to happen is that effectively we learn this new gesture, and we train this model as well on the browser. So OK, we've collected more than enough samples. So let's train this model. So if you look at this, what it's going to do now is it's going to basically train this. And you see there is actually a loss. There is a loss, which means that the model is trying to understand this is actually pretty bad. The loss is actually quite large. So probably let's see if it is actually even working in the first case. So if this is the case, it has to actually go start up, right? So let's see if it first detects. Yeah, it's detecting that it has to go up. Now it will keep going up. Let me try left. It has to detect left. It has not detected left. It thinks it's right. So you see that this model is actually not pretty. Let's restart this and try again. So what should technically happen is that when we are training, probably let me use this mic as one more way to actually train this. So you see that this is actually loading a model called MobileNet, which is basically a neural network which was actually developed for mobile applications. And this is exactly the reason why it can actually run purely on the browser, because it's a very small model and it can be loaded on the browser, and you can actually retrain the model right on the browser. So probably let's come back to this later. One more cool thing that you can do is typically, how many of you have used an app called Prisma? So has anybody heard about this app called Prisma? Yes, exactly. So now you will see how Prisma actually came up with their app idea. So you see that we have 2 images, which is Chicago skyline. Probably I can choose some other image. Say, what is this? OK, it's beach. OK, let's go to beach. And let's say, for example, choose bricks over here. And you see these two, or let's just see what happens before we talk about this actual idea. So what this neural network is doing is it's using a pre-trained model to actually apply this, the style on the right-hand side to the image on the left-hand side. So this does not seem nice. Let's try another model. Hopefully this looks better. And what will happen effectively is that we are actually trying to, let's take Chicago, for example, and see if this looks better. So again, one point that you have to notice here is that this is actually doing everything on the browser, which means that you have to give it fair amount of time that it is actually trying to stylize this image, and it's also trying to do a lot more things just on the browser itself. So you see that there is a lot of motivation for doing in-browser. The reason for in-browser machine learning is because with privacy taking a lot more forefront, the fact is that we need machine learning models that are actually right on the browser. It's running on the browser. So this is one of the reasons why, so you see that this is one of the applications where you can run this. The third thing that I would like to show is basically something called, so for example, this is toxicity detector. So you can write text. So we saw images. What about text? So in this case, yeah, you can already see that. Yeah, so we are dudes on computers, moron. You are quite astonishing stupid. So it actually detects that this is an insult and that there's a toxicity as well in this text. And if you, maybe we can also try something, but I don't want to be obscene over here, but these are some examples of how this toxicity classifier will work. So effectively, what you're trying to do is that the motivation here is that we can actually train and deploy machine learning models right on the browser. So we will come back to the Pac-Man later, probably, once we actually go through this and probably when we see that we have enough time later. So the idea here is that we are going to talk about TensorFlow 2.0 and the high-level APIs on TensorFlow 2.0. The reason for TensorFlow, so how many of you have used the 1.0? I guess a few of you would have used the 1.0 or the 1.x version. One of the biggest pain points that people complained, and people like me as well complained to the Google team, was the fact that it was extremely bad user experience to actually develop a neural network with TensorFlow 1.x. So what happened was Keras was biggest high-level API. So what a high-level API does is it's basically a wrapper around the low-level compute stuff that actually TensorFlow does behind the scenes. So Keras was actually one of the biggest libraries that people were actually using for TensorFlow. And what TensorFlow team realized quickly is that the fact that Keras could be used as a base level API. So in that sense, from 2.0 version, TensorFlow uses Keras as its native API interface. So now, this is a pretty straightforward code that you have here. So this is one of the reasons why, again, Python takes one of the biggest slice of the cake here. So when it comes to machine learning, it has to be very concise and it has to be very, very if you take the code, you have to understand what the code is trying to do. If you see that here, it's a sequential model. The first layer is basically just trying to take a dense neural network. It's a dense layer. There's a dropout, and there's a dense layer again. And if you see, typically, this is, if you see the 10 over here, it's pretty clear that this is most likely going to be an MNIST or a variation of an MNIST where there are 10 classes. So what is happening here is that you have a neural network. I wouldn't say it's too deep. There are dense layers here, and I think there's only a 2-layer neural network. There's an input, there's a dense, and there is an output, which is the output class itself. If you see, this entire thing is the neural network, the neural layer definition, and the final would be basically the train and the evaluation as well. So if you look at this, this is pretty concise. And this is one of the reasons why TensorFlow has adopted Keras as its one of the primary ways in which you can write a define neural network and train and deploy the neural network. We will also see the fact that because of this, but people would prefer to write their own layers, for example. Then what will happen is that you can pretty much write your layer as well and then pass it again back to the existing Keras layers, for example. So in this case, you would probably define, say, 2 dense layers, and then you would want to have a call to one of these dense layers, and then what will happen is, in the end, you will actually get the same sort of this, which the definition over here, but the fact that you will use your own layers that you defined before. So that's how simple TensorFlow has become from the 2.0 onwards. It was simple as well before because Keras was still integrated, but it was not natively integrated in TensorFlow. But now TensorFlow has Keras natively integrated in it. Now, moving forward, so 16th. As of today, what happens is TF has become a part of Keras. But the fact that TF has become a part of Keras Keras has become a part of TensorFlow does not mean that it's going to be, or quite restricted to Keras. One of the most important things with TensorFlow is that you're going to have low-level access to all of the computes. And this is the reason why I will go back here. From 1.x, if you switch your code to 2.x, if you say, for example, wrote code in 1.x on a Keras layers, code would look something like this. And if you switch to 2.x, it would look exactly like that. So that's the best part of how things look with the new API change. The only change would be probably in the import statements that you would write, and nothing much. So the point here is that TensorFlow 2.0 has actually made things much easier for us to actually train and deploy and to actually port the models into, say, for example, to the server or to, say, for example, to the mobile device. So now that we have, so we also probably talk about how we actually used to do RNN, for example, in the 1.x TensorFlow. So with 1.x, what happens is you have to first test if the GPU is available before you could actually do that, because you had separate ways in which there was a CUD and an LSTM, and then there was actually an LSTM layer directly as such. So the LSTM layer does not actually directly scale up. But with 2.0, what happens is that this is directly taken care of. So this is sort of abstracted away, and so that the developers don't have to worry about how you can actually write a layer, irrespective of if this is not an overhead anymore. So this is one of the biggest also changes in the 2.0 version of TensorFlow release. Now, what happens if you would like to build your own layer? So if I want to build my own layer, then typically I would do the same thing. I would actually write this layer. So but the fact that I would actually pass my new layer as a new layer as very similar to how you would write a class in, for example, in Python. So this is how simple it has become. You pass the layers as an option. So basically, your class would be inheriting from the layers of Keras, and then you would basically be rewriting your code, but with the fact that the layers is going to be your definition of the layers and not what TensorFlow gives out of the box. So this is how simple the Keras integration has become now. Now, with structured data, so this data was one of the biggest problems with your deep neural network pipeline. So when you take a deep neural network, your data would actually pass much slower than your GPU would compute. And what happens now is that you can actually pass, earlier on you had to, there was this estimator API as well. And now if you have an estimator API, that could also be passed directly into a Keras sequential model, for example. So this shows how you can actually do that sort of an operation as well. And then you can integrate both of these into a Keras model and then do the final operations like export later on. Now, this is pretty cool. So the fact that you don't have to actually write things for Tensorboard, I will show you an example of how this actually works. Tensorboard now natively is integrated directly into your code, so you can actually log all your results. You can actually see how it's training and how all the model is actually working in real time when the model is actually training. So I will show you an example where you can train your model and see the code simultaneously. There is an experimental hyperparameter optimization as well built right into your code. So you can actually test multiple hyperparameter changes, and then you can actually see the results when the model is actually training. So I will show you an example later on. Now, so this is typically, so because of using Keras now, what happens is that you can actually see the results. So this is how a typical Tensorboard would look like. For example, if you have not seen what Tensorboard is a nice visualization of how your neural network is training, or if you're training, say, for example, text embeddings, then you can actually look at how your embeddings look like, and if it actually makes sense in the hyper dimensions, in larger dimensions, it actually gives you a nice visualization tool. And now what happens is here you can see on the right-hand side is, your left-hand side is basically, it actually talks about the accuracy and the loss. And on the right-hand side is the definition of the layers itself, definition of the neural network itself. So it's a pretty simple flattened, dense, and a dropout, and a dense, and a dropout, and a dense. So it's a very simple definition of the neural network. And you see that this is actually pretty much abstracted, and then it shows how the definition is. So when you're actually debugging this, say, for example, your neural network, when it's actually training, then you already know that if this is what you already wanted to do, or if you didn't want to do this, you can basically kill it and then restart it. So this actually gives you a very nice visualization of how you can actually go ahead with your training and with your evaluation strategies. So one of the other cool things built into TensorBoard now is the profiling. So you can basically see how your file names and how your jobs are basically running. So you can see that the GPUs over here, there are actually 3 GPUs running, and it's actually telling you how your GPUs are actually being utilized. So if you see there are green bars, you see that there are lots of blank spaces in between. So your GPU is pretty much idle over there, and you see that there's data is actually being fetched probably in the meanwhile, and so those times your GPU is going to remain idle. And this is one of the motivations for I'm going to show you how TPUs are going to actually take care of this problem and how this actually gets parallelized and how your training becomes substantially faster. So with this, what happens is the distributed strategy also changes. So this typically, if you have, say, for example, multiple GPUs. So I know I've worked for companies where we have multiple GPUs running simultaneously. There are racks of 32 GPUs that you can actually use to train your deep neural network. For example, if you're training an inception or if you're training an exception or a residual network, you would need multiple racks of GPUs to train your neural networks. And in those cases, what will happen is you would need to distribute your training. So that becomes much, much simpler now. So now what happens is you will have a mirrored strategy, which actually just takes the strategy into scope, and then it simply trains your neural network. So you don't have to worry about how you will distribute it and how this actually, so that there used to be a gRPC and all the other back overhead before, and all of this is now taken care of inherently in the new TensorFlow API. So with the evolution of TensorFlow, now what happens is there's also going to be multi-workers. So this is again going to make training even simpler and faster. So this is one of the new things that, so at the moment TensorFlow 2.0 is in the alpha version. So hopefully by I think Q2, the TensorFlow team has promised that TensorFlow would become hopefully beta or the full version itself is available. Let's see about that. But it should be available very soon, I guess. So having said this, I just want to give you a quick overview of what TPUs are and why is that the fact that we want a TPU at all in the first case. Because first of all, we don't even have GPUs probably, and why are we even talking about TPUs? So one of the good things I want to talk about is the GPUs. As you all see over here, we have gaming tournaments, and these were the guys who were actually reason why we are at this point in history probably today. GPUs were actually extremely good for doing graphics, as you can understand. So this means that it can actually do matrix multiplications for gaming much, much faster. But you see, that is the problem over here. It's for gaming, and it was actually designed for gaming. And we basically got into that, and we took a shortcut, and then we are basically using it for matrix multiplications with deep neural networks. So the fundamental problem was that GPUs were not designed for machine learning itself. It was not designed for training deep neural networks. So with that in mind, what Google did was basically it went back to the drawing board, and then it thought about what were the fundamental limitations with what happens. So if you look at how the GPU works, the GPU is actually extremely fast when you can actually put the data in its format that it's looking for. But the problem was that the data itself was actually the biggest bottleneck. So your CPU was basically throttling down the amount of time your deep neural networks take to train. So what the idea for the TPU was that you can actually parallelize this immensely, and this is what the TPU takes care of by actually using something called a systolic array. Probably we can have a separate session on how the TPU itself works. But the fact that the TPU actually takes care about high performance and basically taking about how you can actually do the cutting edge model architecture, you can use this to basically make your training faster, your deep neural networks much, much faster. I will show you an example as well. We can train it simultaneously with a GPU and a TPU and see how the training actually goes by, and we will see the results. Probably if there's time, we can actually train it right in front, or if there's no time, then we can actually see the results. So it was trained probably this morning. So yeah, I will just give you an overview there. So the fact that one of the biggest gripes with Google Cloud and all of the cloud service providers was the fact that it's pretty expensive, I would say. For me to actually train something like, say, on a TPU, it would typically take $4.95 US per hour. In Asia, it's $5.22. That's okay. I would say it's good because if you're considering deep neural networks and if you want to train a deep neural network, you would like to have something that's fast. And in this sense, you can actually run multiple experiments. And especially if you have like a large research team, you would like to have access to such resources because you would like to actually test a lot of simultaneous experiments and get some results quickly. But this, what could be this? Well, if you can preempt this TPUs, which means that you actually tell Google Cloud that you actually want these for so much hours, you can actually get probably a better rate. So you will probably get like 1.48 if the server, if the TPU's pod is going to reside in the US, and if it's in Asia, then it's typically 1.56. But what could beat this as well? Well, the fact that it can be done for free. So this is what I'm going to show you now. So how many of you have heard about the Google Collab? Okay, basically 3 or 4. That's fantastic, because the fact that I can actually tell you what the Collab is. So the Google Collab is basically, to put in simply, it's basically a Jupyter notebook running on a server. But you see, it's a fancy Jupyter notebooks, and this is one of the reasons why the Collab has actually been very, very successful. What will happen is that you see, this is basically, if you've used a Collab, or if you used any Jupyter notebooks, typically you would see that there's a cell. So on the top is a comment cell, and typically there are cells where you can actually run typically any programming language. So Jupyter was probably an amalgamation of Julia, Python, and R. And this is one of the reasons why it's called Jupyter, as with the PY. And this is the reason why people prefer Jupyter notebooks, because you can choose to run the kernel that you prefer. So I could, at the moment, I think even it supports other languages, like I think C++ as well. There is an experimental C++ kernel build. So what you can do is you can create a server. You can actually run, I'll probably do that in front of you now. But the idea here is that you can run all your experiments on a browser. So the reason why a browser is nice is you can actually write code blocks, and the blocks will run independently of each other. So basically, I can do a quick debug of, say, for example, a variable, and see what is there in the variable. And before even I run the next batch, or before even I run the next block of cells, I can actually look at the results and then see if I want to proceed or not. And in the end, if the results look good, then I can download it as a Python script. So this is one of the reasons why the Jupyter Notebook is actually one of the best, or the preferred ways of actually doing development these days, especially for machine learning and for data science itself. So probably I will give you, I will show you how this is also going to work. If you look at this slide here, first of all, when you actually, like I showed you over here, you first change your runtime type to basically to use TPUs. And subsequently, once you do that, you can actually get your device. So to know that Google has allocated a TPU, if you do this device name, and if you can get the address allocated. If you typically see that it's none, then unfortunately Google does not have the resources to give you. But if you see a number, or if you see what you would like to see, is basically an IP address, then you're at luck. So you can actually do the training, and then you can actually do it for free. So this is what I'm going to show you now, and how this is going to be useful for you to train your deep neural network or any machine learning model, for that example. And one of the reasons why this is also very nice is the fact that you can actually train this, and you can actually export it into a CPU-only inference model as well. So you can train it on a TPU, and then you can port it back into a CPU. And in that sense, you can actually keep things much, much easier. So to actually train for inference on your CPU, for example. So just to sum up, what Collab is using is basically the TPU version 2. And probably I'll stay over here. And it has an 8-core, and this is what I said, it's got a systolic array, which means that the computes are going to be in sort of like a wave, and batches of 128 per core. And this is one of the reasons why you see there's going to be typically 8 into 128 sort of batches every single time. And you will do a batch size of 1024 for that reason exactly. And yeah, so you can also use smaller multiples. But we will see this when we actually do this together now. Probably, yeah, let's check out the code. Let's not keep talking again. So now that we are here, let's quickly run this. So typically, when you start with deep learning, you will go with MNIST, which is the standard hello world of machine learning. In this case, I wanted to be a bit more fancy. So I took something called the fashion MNIST, which is basically the MNIST, but a much more fancier, probably, I would say. So if you see, okay, so before I go deeply, or before I start talking about what's there, if you look at this is what a Collab is. So this is what a Jupyter notebook would also typically look like, but not so fancy. But the Collab allows you to actually define on the left-hand side, you see there's going to be sections. You also have code snippets. So for example, if I want to download code, and if I want to see that, okay, this is how I want to download code, you can actually get code snippets right from the code there. So you have most widely used code snippets, and you can actually search for it, and then you can actually get these code snippets right into the cells that you have. On the center, you see there are multiple cells. So these are the, if you see the cell with just a box around it, it's just a comment cell, which means that you can actually write about it, and you can actually give some information about what this notebook is actually doing. And typically, yeah, if you go through this, I will share this link as well. You can also run this by yourself, and you can see the results. Typically, yeah, so what I do is here, the nice thing is that Keras has its own inbuilt data sets, which means that we can download fashion data set directly into the browser. So it downloads everything. And when you actually allocate this, so what happens is you see that Google actually allocates you some source, some location on its, it actually creates its own sandbox, and then it lets you download your code or save something as and when you actually run this code. So as you might see, just like in the slides that I showed, you will have a model definition over here. This is it's a typical deep neural network now. We have a batch normalization, and then we have a convolution, and again a batch normalization. This is, I think this is probably a 555, so something like a smaller version of a VGG or some version thereby. So it could also be a lot of other variations. But yeah, this is a very simple deep neural network definition. And if you used Keras before, it actually shows you the exact layer. And this is pretty nice. So especially if you're looking to do data science. So for example, if you want to understand how to optimize a deep neural network, this would be the step when you actually define it and then take a step back and see if this is what you would like. So if you see the total parameters down, it'll actually tell you what are the number of parameters that you have and what is it that is actually training. So let me just quickly make this larger so that it's much more visible. Yeah. So on the top is basically the neural network definition, and at the bottom it's going to say there are 1,619,470 parameters. So what this neural network is going to do is it's going to train on 1,619,084 parameters, which means that this is going to be the amount of time the neural network, the weights that this has to store onto, say, for example, a physical disk, if you're going to save it or if you're going to export it. So all this is going to happen. So, and there are 386 non-trainable parameters. There could be some constants that we are defining somewhere, and this is one of the reasons for that. So now that we know all this, so typically you would want to take a step now. You would like to say, I would go ahead with this training, probably because I have a lot of resources I could actually use. So I would still go ahead and I would start the training. So like I showed before, you can actually train this pretty easily on the TPU. So it's very simple. It's very similar to how you would train with a Keras, but it's just that you have one more wrapper around it to ensure that this Keras model is actually going to take directly from this Keras, and then it's going to put it onto the TPU because, like I said before, there are systolic arrays, and you would like this to be distributed for the fastest performance. And if you see, this cluster resolver is going to say automatically that it's going to take a Collab TPU address, and then it's going to train this directly. And yeah, so this is a typical compile train cycle that we are going to have. And we are going to also, this model is also going to produce some batches of data, and then it's going to train for 10 epochs. And if you see, first it's basically doing, like I said before, 8 cores. It's going to allocate 1 TPU worker, and it's basically training this neural network. So at the end of 10 epochs, you see that I've actually killed it at the 9th epoch because it was already good enough. I'm already at a loss of 0.2. And if you see the accuracy, I was already at 99% accuracy. So now that we did this, we actually go forward and then we see the results. So again, one of the important thing to do as a data scientist or a machine learning engineer is to not just do this data massaging part, but also to go ahead and look at the results. And the cases where it actually fails is more important. And this is one of the reasons why you always see from the test data, you actually see if your data actually looks exactly what like it should look like. So if you see the results, it's pretty much good because you actually have to take some random samples. But so thankfully, in this case, almost all the samples are pretty good. We will probably do this multiple times usually if you have a lot of time available. But since you don't have enough time, we'll just take it as at this face value and then we'll go ahead. But just to compare, so here we have this GPU, sorry, it's a TPU running, and we took probably about 52 seconds per epoch, if I'm right. So probably about 58 seconds, and the worst case was 65 seconds, or 82 was the first, but 65 has generally been the constant average, I would say. So if you switch to the GPU version, if you see the runtime here, it will be a GPU version. And in this case, what Collab allows you to do is it allocates a K80. So the TPU is basically one part, and the GPU is a K80 that it actually allocates for you. So it's not the fanciest of the GPUs that you're going to get, but you're still getting it for free, so you cannot complain there. So if you want to get some of the fancy GPUs, then you can of course go to Google Cloud, and then you can get the GPUs there, or you can of course go to Amazon, or any other cloud provider would still be good for you. So in this case, it looks like I killed it before it was trained. So let's just run this right here. And probably while it's training, I could also quickly take some questions if you have. Let's make it interactive. If not, then we will just look at the screen where it's actually going to train. So this is your time when if you have any questions, you could ask me or look at the screen and yes. No, I'm not good. I'm not finished yet. Don't worry. But
so far, thank you so far for such a practical seminar. And so there are two questions. First of all, the disadvantage of Jupyter is a good way for prototyping, checking, proof of concept. But then when you're gonna train it for thousands of epoch, you usually put it in console and use it Python.
Yes.
So you do it because if you close this web browser in Jupyter, you lose the output.
Yes.
Of course, the dashboard, the Tensorboard helps, but sometimes you want to save more images, not to send it to the Tensorboard server, and you save it on your disk, HDD on your server. But here, do we have the file server here? Can we upload our dataset? Can we close so all these questions?
So
Thank you.
That's a wonderful question. So the point that I would like to note here is that because it's free, so typically, so you don't get access to all the fancy things there. This is again, so that's a problem with any Jupyter notebook. So you cannot put some notebook to basically, you cannot make it run in the background while you're basically taking a nap. So that's not going to happen. You can, of course, go to any cloud service. Of course, if you're running a GPU in your end, then of course you can do a no-hop or any of the, so you can do a screen or tmux, or you can put it to train, and then you can just log everything while it actually trains. But I do agree that you have to wait for it to finish. Yes, that's a problem. But on the other hand, I would say this is for free. So you're getting compute resources for free. So this is excellent for experimentation. So if you have a new neural network idea, or if you'd like to train, say, test, for example, one, say, object detection or a segmentation idea that you would like to test, and you want a basic idea of whether this neural network even trains, and if you want to do it quickly and you don't have GPU resources, this is a perfect. So if you want to convince your, say, for example, your advisor, or if you're in grad school, or if you're in your undergrad, if you're in university, if you want to convince your, say, your computer science department that you need a GPU, this is one of the ways you can if you're in a company, then this is again one way to convince your manager that this idea works, but the fact that this is going to take a long time and that this might potentially take company resources on the Google Cloud is one of the reasons why you can convince your manager to get you, say, some Google, say, any cloud or a GPU locally. So that's a perfectly valid point. But the idea here is to show how you can experiment things and how you can get things working even before spend any money on it. So So did I answer your question?
Yes, that's a brilliant answer. And let's go forward. We have time as far as this is. So what about uploading datasets? What kind of datasets supported? Only the ones which are supported by the TensorFlow dataset module or kernel?
Yeah, so I'm going to come back to that. So this is also a part of my presentation towards the end or towards somewhere in the middle. So where we have about 20 minutes to go. But the idea is that you can also upload your data set and get it in a standard form. You can, on the Collab, yes, of course, you can upload your data set. If you look at the code snippets, you can actually see upload. And you see that you can actually upload files from a local system. So, which means that it will give you a nice UI where you can click and then you can choose your file and then you can put it out there. What will happen is it will put it into a /data/ your file name. And then you can, just like how you would read any file, you could read it from here. Because this is not my computer, unfortunately, I cannot show you how it works. But yeah, typically, this is what you could do. You could go to collab.research and then .google.com, and then you can try this out for yourself. So yeah, this is, the code snippets are very, very useful in that sense. One neat feature is also that you can actually save your data directly into your Google Drive. So if you look at this, it actually gives you the code for directly saving your files. So if you have trained a model and then you would like to save it into your Google Drive, you could do so directly. And yeah, this is pretty neat in that sense. You can upload and you can save it simultaneously as well. So it does not go into some place where you don't know where it exists. So yeah. Okay, so if you see, yeah, finally our deep neural network took, even though it's on a GPU, you see that it has taken 256 seconds just for the first epoch. So let's not waste our time too much here. Let's continue while it's training in the background, and then we can come back to this quickly later on. So yeah, one more thing that I wanted to show here is that TPUs, again, TPU strategy is also going to come in, and we're going to have better ways to even experimentally, we can change this TPU strategy, distribution strategy on the TPUs as well, which means that we can allocate, if you have, say, an array of TPUs that you have available, then you can also get that into action, which means that it's not just faster than a GPU considerably, but it's going to be even faster because it's going to be parallelized on multiple TPUs. So having said that, so I'm going to answer your question now. So here, this is one of the nice things with the TensorFlow 2.0 version with the data sets. What happens now is that one of the biggest problems with a lot of data scientists or machine learning, people working on machine learning projects, is that data sets is a bigger problem. So generally, you will download different data sets. The partnership between basically the data and the model has always been a big problem. So if you look at this, it is always messy. So you need to always get this trained data set somehow, and then you need to put it, and then generally this massaging is always not good. So this partnership has to be very good. So in general, if you have your data well made, and if your model, you're going to basically have a very nice partnership. And this is exactly where this data sets API comes in from TensorFlow. And if you see what happens is with this case, this is exactly the line that this data sets library is now going to target. So here, this is basically the idea. So you have a high performance flexible input pipeline. So basically you create your data set, you do all your manipulations. You want to say, for example, pre-process this data set. You want to shuffle it. You want to get all the prefetch. All this is done with one single, a few lines of code. So the point here is that I wanted to say is this one. So if you look at MNIST, if you look at, say, for example, different other data sets, you see it's all going to be in its own versions. So it's going to be in its own format. It's going to be in its own way in which it's actually shared by the authors. So what TensorFlow has done now was basically, again, like I said, it's going to make this partnership together better. And in that sense, what happens is now you can do import TensorFlow datasets as TF data DS. And if you look at this, you can actually load MNIST directly. And not just MNIST, but basically you can do ImageNet as well, 2012 model directly from here. So which means that you get a nice trained test set directly out of TensorFlow datasets. And you get, say, for example, not just images, but also text, for example. So you could do this even for text. And this way you have a very nice pipeline, which you don't need to change much. If you want to probably switch between, say, CIFAR 100, CIFAR 10, all you have to do is just switch the load call, and then your data would basically be the same, and hopefully the resolution is all you already know about it beforehand. But this is very nice in that sense that it actually comes in neatly abstracted, and all you have to do is change the key in which you want to retrieve the data. So yeah, that's, did I answer your question here? So this is exactly what's going to happen with the 2.0 release with the TensorFlow datasets. And yeah, of course, if you'd like a bytes version, then you could also do that. So there are various tasks and various ways in which you can download it. This is one of the important things that I wanted to share. It's basically how you can pre-process the file and process it as a data set, and you also get that info. Probably because of time, I will probably skip this at the moment. But yeah, you can go back to TensorFlow datasets, and then you can actually understand this in much deeper context. But one more important thing for typically for people who are interested is basically that if you download this data set as a TensorFlow data set, you can also have the chance of exporting it as a NumPy array. So people typically want it as in different formats. And NumPy is one of the biggest formats that people actually like it. And in that sense, TensorFlow data sets actually allows us to do that as well. And yeah, you could do it in 3 different lines, so it's just way. And the easiest way to install TensorFlow datasets is like this. So you do a pip install TensorFlow datasets, and yeah, if you go to TensorFlow/datasets, you get a more detailed overview. There are 30 plus datasets on the datasets. So if you see on the right-hand side, you actually see for multiple modalities, audio, for example, images for text, and there's also for videos. All of these are actually available on the TensorFlow datasets page. And one of the important things is that if you have your own data set, for example, if you're a research student and if you actually have created your own data set and you would like your research community or the community in general to have your data set, this is one of the best ways to do it. So you can go to the TensorFlow data sets, and there's a format in which you can actually submit your data set, and then the community will have it in the same format as all the other data sets that are available. So if you're interested, you could also go to this and add your own data set, and yeah, you can share it with. And this will be a typical nice topic for you if you're, say, for example, defending your thesis. And if people in the community agree your data set is valid, then this is a nice thing to actually share with people. So yeah, so go ahead and then share your data set on GitHub. So finally, and I think because of time, I would like to quickly skim through this. TensorFlow Hub is one of the biggest, I would say, ideas that's been available. It's been there for quite some time now, but it's slowly getting a lot more mature now. The idea is basically use TensorFlow Hub when you have data that's actually sparsely available or not much available with you. And typically when you have less domain expertise and when you want to share without all the other code dependencies. I will show what that means. If this is the first time you're looking at TensorFlow Hub, typically what will happen is you have your module and you have the repository that's there. What will happen is typically you can just take the model out of the repository and then you can share it you can use it in your data. So I will show you how that actually works. The idea is that here, these are some new ideas that are coming about how it's actually going to be integrated directly into TensorFlow, into the core APIs, and how there are actually going to be new saved model features that are available at the TensorFlow Hub. But let's see how this actually looks like. So if this is the first time you're looking at TensorFlow Hub, what happens is you can actually load, say, typically something like if you've used for text classification, for example, you would download, say, a glove or a word-to-vec embedding, and you would have to download it again in some random model that the author would have chosen to develop it. But what now Hub does is it basically gives you all these embeddings that are available, and it's actually available commonly. Typically, this is the NN, the LM model, basically for, again, 128 MH. If you go to the Hub page, you can actually download the module itself. So typically, this will allow you to get the embeddings. And the cool thing about this is the fact that you can actually do this, you can actually switch it for not just for text, you can do it for images as well. So if you're going to run Inception, if you're going to run MobileNet, you can actually download directly the features from the module directly. And TensorFlow Hub lets you directly take it out of the box, and then if you're going to do, say, for example, transfer learning, then you can actually do it with the Hub itself. So this actually directly feeds into the model. And yeah, I just want to probably go through this. I'll probably just skip this. But if you go to tfhub.dev, then you can see that there are, again, multiple different models that are available already. And you can actually get images for videos and for, say, for example, from trusted publishers like Google and DeepMind itself. So you can actually see there are multiple models available exposed by Google and by DeepMind. And one of the pretty cool things that I wanted to share is something that I have found recently is that if you're typically looking at a trained task, say for example, if I want to say, if I'm saying something in English and if I want to say the equivalent in say for example German or in French, I would have to essentially do this once again for French, once again for English. But what will happen is now you can actually do this across different languages. So which means that if I say some sentence in English, it will be simultaneously, it can be changed into multiple such languages. And I think one of the things that the Google team is doing is to come up with all the variations of this in, so the idea here is that this is a shared space. So which means that I can effectively talk in English and hopefully in 1 year from now, the language actually gets translated automatically in Romanian, for example. That could be one feature that is pretty cool. And effectively, you can actually do this for any language. I could do this for German, and you don't have to train a German to Romanian translator, but it could be the fact that because it's a shared space, it could actually, you can just use a German embedding simultaneously along with the shared space, and then you get equivalent Romanian embeddings, for example. So this is a pretty cool feature, and this is one of the reasons why machine learning research is pretty nice, and this is one of the reasons why I keep saying that this is one of the best times to start learning about machine learning, because you have so many resources and almost all of them are available for free. So yeah. And yeah, so this is one more feature. If your image augmentation is very important, especially if you're going to train a deep neural network for image classification or object detection, and this comes out of the box with the Tensorflow Hub. And yeah, of course, there are more models. For example, BERT comes out of the box for Tensorflow Hub. You have object detection. Big GAN, for example, is also available directly. There's also progressive GANs and text and image features. And yeah, some video action recognition is also available from the hub itself. And yeah, so to summarize, I would say if you're interested in some resources, the main takeaways I would like you to take is there's a seed bank. So if you're actually looking for inspirations of what you would like to actually start or where you would like to start some experiments or some algorithms or ideas, then the seed bank is one of the best places where you can actually search for, say, for example, an image classification or image object detection. And everything is available as a Collab notebook. So if you go to the seed bank, you will actually be able to get the corresponding notebook directly from that, and you can actually start your object detection or text classification task right from the seed bank. A very cool thing that I actually showed you, the TensorFlow JS is available again. If you're a web developer, TensorFlow JS would be very, very interesting for you. So I would highly recommend going to TensorFlow JS and then looking at it if you're interested. The model garden is again where there are multiple models that people expose, and you can actually get it from the model garden. And that's also from Google, that's also from the community. So yeah, you could get different models that are exposed by different people. Some more resources. If you're an iOS developer, a very nice cool thing is Swift is available directly for TensorFlow now. So go ahead, enjoy it. If you're an audio engineer, if you're interested in synthesizing audio, then Magenta is a very nice project that you could actually use. This is actually based on the Magenta project. You can go to the site and you can actually get more resources, an idea about what the Magenta project is all about. And if you're a statistician, then you would be highly interested in the TensorFlow probability library, which is basically going to explain the variance and bias in your model. And it's pretty nice. So I would highly recommend, if you're especially interested in the mathematics behind different machine learning models, then the TensorFlow probability is one of the best resources to go ahead and then look at for. And if you're starting, so this is one of the important things, if you're starting with machine learning, I would highly recommend that there is this machine learning crash course. Typically for software engineers, this crash course is actually very cool. It explains all the machine learning jargons, and you would be able to immediately start with, say, a machine learning project at the end of the course. So this is if you're interested purely from a software engineering point of view. There's this AI for Everyone. This is by Andrew Ng, and this was released recently. This is actually one of the best, again, courses for if you're really interested in the mathematics and all the ideas behind the machine learning, behind deep learning, then you can actually go for AI for Everyone. And yeah, so there are more resources in the gallery. So if you go to the gallery, you'll see a lot more projects like I showed before. You can actually go ahead and then see that for yourself. So that's pretty much it. If there is more time, I will probably show these as well. But yeah, mulțumesc. Thank you.